So this question is from the MSTE 001 and 7th question. And a small electronic device is designed to emit a timing signal of 200 milliseconds duration. In the production of this device, 10 subgroups of 4 units are taken at periodic interval and tested. The results are shown in the following table. Subgroup numbers are here, the 10 subgroups numbers, and duration of automatic signal for A, B and C are given here. And first question is estimate the process mean and standard deviation and determine the center line and control limits for process mean and process variability. And third one is by plotting the charts on graph paper, determine that the process is stable or not with respect to the process mean and process variability. If necessary, compute revised control limits. So first we have to draw a chart table of this first of all subgroups number and duration of all the automatic signals are here A, B, C, D, and then we will find the x bar and r. So in the last two columns x bar and r we will find. So for x bar we simple plus all the 195, 201, 194 and 201 upon 4, and we will get 197.75 in the x bar column. And this is the r is the value of the r is calculated by the maximum number minus minimum number, where maximum number is here 201 and the minimum number is here 194. So it means that 7 is the range of this first subgroup number. Now similarly we will find all the values here. Now the first question was find the process mean and the standard deviation. K is equal to n equal to 4, sigma x bar is here and sigma r and r bar is equal to 12.1. So the process mean is that estimated by grand sample mean, which is calculated by x double bar 1 upon k summation x bar is equal to 1 upon 10 into 1987.75. It means that the x double bar means the process mean 198.77. Now we will find the process standard deviation, which is estimated by the range and which is calculated as follows. So sigma cap is equal to r bar upon t2. This is the formula of sigma cap, and we will find putting this value sigma cap 5.719 is the value. Now the second question is the control line and the control limits for process mean and the center line and control for process variability. For process mean we will find the x bar chart. So x bar chart, for x bar chart, x double bar plus a2 r bar, x double bar minus a2 r bar. So we will find all the values by putting these values, and by simple process variability CL r bar, D4 r bar and LCL D3 r bar. So we will put this also and find the control limits. Now the next one is the x bar chart, which is here. First is x bar chart is here. So and the second one is r bar chart. So r bar, in the r bar chart we can see here the in the horizontal line the subgroups number are here, and for the vertical line all the signals are here, and I drew a UCL, CL and LCL from my data. CL is 198.77, UCL is here and LCL is here. So I will plot this lines here, and the observations of x bar chart is in the second last column. So I will put all the values in the x bar chart, and after we see that there is no point outside from the control limits, so the our process is under statistical control. Now the r bar chart for process variability. So similarly we will see here LCL, CL and UCL from the LCL. CL is 12.1, UCL is 27.61 and LCL is equal to 0. So we will put these values in the graph. In the horizontal line sample number is there, and the vertical line is range of the duration of automatic signal, and we will put R values in this one, and we see that the only one point is outside the control limits, which is the fourth subgroup number, which is outside the control limits. So we see that the point corresponding sample 4 lie outside the control limits. Therefore the process variability is out of control and some assignable causes are present in the process. For calculating this revised control limits, for now we will find the again R limits. We first delete the out of control point and calculate the R1 new for the remaining samples. Now R1 new is calculated by sigma R minus sigma Rj upon K minus D. So we simply see that sigma R was 121 and minus 31, because the 31 is the number which is outside the control limits, and 10 minus 1, now R bar nu is equal to 10. Now the value of CL, UCL and LCL is again 10 and 22.82 and 0. Now we will again draw a graph of new revised R chart. So in this we can see here there is no point outside the control limits. So it means that our processes is under statistical control of process variability. So thank you so much. If any confusion you can point out in the comment box, and you can ask me about that, what is the problem in this question. Thank you so much.